is that we're going to talk about function family. Function family. And we have functions that belong to the same family, and they share key characteristics, kind of like you probably look a little bit like your parents, right? Lucky me, I look like my dad. No? Okay. Anyway. So functions in the same family are transformations of their parent function. So like we have a parent function, and then underneath that parent function it has lots of little babies. They kind of look like the parent, they're just different in a little bit of way. That's kind of what we have going on here. I put on here 4 main parent functions. 4 main parents that we're going to talk about today. The 4 parent functions, there's more, but this is what we're going to talk about today. The 4 parent functions are constant, linear, absolute value, and quadratic. These you've probably seen somewhere in math class before. I know you've seen these because we were just doing these. So constant is a 0 slope. It's a function with 0 slope. Doesn't go up, doesn't go down, it stays constant. That's constant. Linear, it might have a positive slope or it might have a negative slope. Linear either goes up or goes down, and it's a line. Linear, first 4 letters, line. Absolute value. Absolute value looks like a V every time. Absolute value looks like a V. How can we commit to memory that absolute value looks like a V? The V in value. And then quadratic is a squared function. You see right here, it's got x squared. This is why it's a squared function that has the word quad. So quad means 4. Square is like when we're talking about area and you take like a square and you multiply s times s and it gives you s squared, right? Area. So that's where the quad part comes because squared has to do with a 4-sided figure. Area. That's where the quad comes from. But it is squared. Looks like a U shape. Do you guys do this before? Yes. Okay. Algebra 1. Now you'll notice that all of these start with f of x. We say that as f of x. That's how we say that f parentheses x. We say f of x. What that stands for is it stands for the value of the function at a given x. So the value of a function at the given x. That is y. When we do like put in x, get out y, when we do that in an equation, f of x is the same thing. We talked about this yesterday a little bit. F of x is just like a fancier way of writing y. It's because it means the value of a function with a given x. That's what it means. But we yesterday talked about it. It's just like y. Now the domain is the input values into the function. It's the input. Domain, when you look at it visually, is how far to the left and how far to the right does the graph go. The input values are the left and right values. They're on domain axis. Domain. On domain axis. The main axis. Get it? Come on, give me something. Okay. I made that up this morning. I thought it was clever. Anyway, which is the main axis? The x-axis. Domain axis is x. Then the x values are basically the range. Domain. The range is the output of the function. It's the numbers we get out. It will be the up and down. It's going to be the y values. The output is the up and down, the y values. So for the first family, for all constants, they're all horizontal lines. All constants, they're just horizontal lines. How far this way and how far that way do they go? Forever. So we say all real numbers is their domain. And then for this one, this is the parent. The parent crosses there at 1. So how far up does it go and how far down does it go? It's only at 1 number. It's just at 1. That's the only y value. Every single ordered pair would be y is 1. So that is why our range is just y equals 1. So for linear, we've got a line. It could be this way or it could be this way. How far to the left and how far to the right does it go? Forever. So all real numbers is the domain. How far up does it go? How far down does it go? Forever. Even if it's like this way, still down, up. So all real numbers is the range. Absolute value. How far to the left and how far to the right does it go? All real numbers. How far? I'm going to start with the lower number. How far down does it go? So I'm looking like this is the lowest point on that V. What does y equal at that lowest point? And then from there, that lowest point, it goes up and up and up and up. So we put our range as y is greater than or equal to 0. And then my quadratic, my U shape, how far to the left does it go? How far to the right does it go? All real numbers. How far down does it go? So we're looking at the y values. What's the lowest y value? 0. And then from there, it goes up and up and up and up and up. So y is greater than or equal to 0. So that's how we're going to write our domain and range. So that's one big thing that we're practicing today. Now the next thing you're going to use a bunch in your assignment today and like, I don't know, like the rest of the year, ish. These are going to be parent function tables of values. So what I'm going to do is I'm going to pick some x's and then we're going to fill in the y values for the parent function, for the mama or the dada. All right, the parent function. So the linear parent function was just on the previous page. It's f of x equals x. That was the linear function. That's the same thing as y equals x, just f of x instead. So I'm going to pick -2, -1, 0, 1, 2 as some x values, and you can pick whatever you want, but this is just what I would suggest as good values to pick. And then what we're going to do is we're going to put them into this function. If I put in -2, this is what it looks like. What is the value of the function when x is equal to -2? So there's x. I'm going to make it equal -2. What's the value of this function now? Y equals x. If x is -2, what's y? Yeah, so that's like a fancier way of saying what I just said. If x is -2, y is -2. So if x is -1, what is y? -1, 0, 1, 2. This is the parent function. They have the same numbers for linear. Parent function for absolute value is f of x equals absolute value of x. I'm going to use -2, -1, 0, 1, 2 again. And I'm going to say, if I put in -2 for x in this absolute value, what do I get out? I get out a +2. So the value the f of negative 2, the value of x when it's negative 2 is equal to positive 2. When I put in negative 2, I get out positive 2. So if I put in negative 1, what do I get out? 1. If I put in 0, what do I get out? 0. What if I put in 1? It's still 1. The definition of absolute value is how far from 0 on the number line is that number. So how far is 1 from 0? 1. It's still positive, but how far is negative 1 from 0? 1. Quadratic is f of x equals x squared. And I use a few more points for this. I do negative 3, negative 2, negative 1, 0, 1, 2, 3. And then I put it into the function. If I put in a negative 3 into this parent function, that means I do negative 3 squared. That means I do negative 3. Are you coming back far enough? Here's the assignment, just in case you don't come back. I put negative 3 in, and then I multiply it by itself. That's negative 3 times negative 3. What is it? 9. Positive 9. Remember when you multiply negative times negative, it becomes positive. And we got 4, 1, 0, 1, 4, 9. I just did that really fast. That's just me putting each of those numbers into the function and getting what I get out. This is the parent function. You need to know the parent function. As you're doing your homework, you have to know it by tomorrow, but as you're doing your homework, have this handy. So looking at these, we're not going to take a whole lot of time to spend on these, but look at this. What function family do you think this one belongs to? Linear. How about this one? What function family is this one? Constant. What about the third one? Quadratic. And that last one looks like a V. Which one's that one? Absolutely correct. Absolute value. And then the equation, we just already went over that was like f of x equals x. This one's different because it doesn't hit at 1, it hits at 2 on the y-axis, so this would be f of x equals 2. That's not the parent function. And this one is f of x equals x squared, and then f of x equals absolute value of x. That's a bunch of vocabulary. Now we're going to use it. Identify function family. Don't yell it out. What family, don't yell it out, write it down. What family do you think this one belongs to? And then we're going to find the domain and range. But you write it down what you think the family is. Edwin, what do you think this is? Absolutely. Absolute value. Domain. Domain. Oh, that's not a box. Okay. Domain. Taylor, how far this way and how far this way does it go? For this one. How far does that line go? Does it ever stop? How far does that way? So then what if it never stops? What do you write? Do you know? Okay, let's go back a page. So this is what happens in your notes. You're like, oh, I don't know that answer. I better go back and look. So we don't know that answer. Let's go back a page. Taylor, help me out. Which one looks like the one we were just looking at? So what is the domain? All real numbers. If it goes on forever in both directions, all real numbers. Yeah, if you know that, I'll show you right now. Thanks for asking. This is better than up there. The symbol for all real numbers, if you don't like writing all real numbers every single time, it looks like a big R, capital R, but it has an extra line on it. So you can write that instead of all real numbers. But you have to know what it means if you're using it. Who asked that? Oh, was it Brian? Good job. Stop hiding. Good job, Brian. All right. Range is how low does it go, and then how high. So how low to how high. Let me call it Morgan. How low, Y value, what's the lowest it goes to?
1.
And then does it go above it or below it?
I go above.
Above? Go ahead.
So it would be Y is greater than or equal to 1.
Perfect. Y is greater than or equal to 1. So you just have to go through those thoughts. Okay, here is another one. Family, domain, range. Isley. Can you tell me what family from the front page this is? Front page. Which family? Available? No? Which picture does that one kind of look like? You see how it's like, which one goes? This one here? Quadratic. Excellent. Quadratic family. Who wants to give me the domain? Left or right? Anybody, please. You want me to just call it on you? Everyone will volunteer. Morgan? All real numbers. So you can write the symbol or you can write out all real numbers. Either is fine. Nope. You can write the symbol. And, ooh, Emmanuel, can you give me the range? Okay, I heard Y is greater than, but then I lost you after that.
No, I said not the x-axis.
What did he say, though?
I said Y is because
But that's not the x-axis.
Did you not say?
So you didn't go on the grade, you said Y.
Yeah, I'll help you do that part, but are you not saying equal to?
I said equal to.
Okay, that's part I couldn't hear if you were saying. Okay, so you said equal to, and then you said 3. Is that what you said? Right, you're looking at the wrong axis. So when we do range, that's up or down. So we have to think about like up or down. And what's the lowest Y value? That's not 2.
Oh, yeah.
You see it? You see it now?
Yeah.
Yeah. So it's kind of tricky until you kind of get used to it. Just why I'm randomly calling you out on it. For you. All right, we're almost done. How much time we got? Not much? Probably not much. 8 minutes. Okay. So it's going to go a little fast. Take a note. We're going to start transformations, but you guys have done transformations before. So this should go fast. This looks like in geometry transformations. We're going to do it with functions. There's 2 transformations we're going to talk about today. Just vertical and horizontal translation. That means a slide. So I wrote in this vocabulary box, I wrote slide, but you're not going to use the word slide. You're going to use the fancy vocabulary. Because now we're in Algebra 2, we can use big words. So if you look right here, we've got 2 examples of vertical translation. We have y equals a parent function plus k, and k is just some number. That means we translate up. Or if you have the parent function take away k, then we translate down. So if it were quadratic, this would be something like y equals x squared, that's my parent function, minus 3. That would translate down 3 units. So we have whatever the parent function is, and then subtract or add. That's vertical. But then horizontal is different. Horizontal says inside of this function, if I subtract h, that is a right slide. That goes to the right however many units. And inside of the function, If I add h, that goes left. Isn't that kind of confusing? Because when you say right, you normally think plus. This is opposite of what you would think. Horizontal, it's like always opposite operation of what you see here. Horizontal is always opposite. It's always inside the function, which might mean parentheses. Most of the time there are parentheses, sometimes not, and we'll go over like a case where there isn't. But like if it's inside of the parent function, it's horizontal. If it's outside of the parent function, it's vertical. This probably won't handy when you do your homework because it can get confusing until you know it. We're going to do it in almost every single chapter of this entire book. So leaving this class, you should know it. So here's our first example. G of x equals x minus 4. So first thing you're going to do is try to figure out the parent function. So which of our 4 parent functions have an x by itself to the first power, not absolute value, not squared, has an x? Which one? No, constant doesn't have an x. What? Look, here's a constant example. F of x equals 2. There's no x in constant. So which one has just an x? Linear. So our parent function, this is linear. You don't have to write linear, but I am. Parent function is f of x equals x. From there, can we tell if that minus 4 is inside the function, or did it happen after the parent function? Here's a hint. Is it in parentheses? Okay, so then it's x first, then minus 4. Yeah? So it's outside of the function. So it's one of these two. It's a vertical. It's outside of the function. Which one is it? Is it a plus a number or is it a minus a number? It's a minus 4, so that means we are doing a down. So what we write is we write translate down 4 units. That's our transformation. Then on our graph, what we're going to do is, and it says it more clearly in your assignment, is we're going to graph the parent function and we're going to graph the transformed function. So in your parent function, you have the ordered pairs on the previous page. It was like -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. You're going to graph this, but you're going to graph them dashed. So you use your straight edge, make a dashed line. And then, since we are doing a transformation, we translate down 4 units. All you have to do is take each point, every point from the parent function, and move it down 4 units. Every dot, move it down 4 units, make a new dot. And that one would be the solid line. We're just transforming each dot down 4 units. That's how easy it is. It asks for domain and range, so left to right is all real numbers. Up and down is also all real numbers for that. We totally don't have enough time to go through all these other examples. So what I would encourage you to do is we're going to have a small quiz tomorrow. I would encourage that you definitely do all of the homework that has to do with the quiz, which I'm handing you right now, so before you leave, you can see. All the homework that has to do with the quiz is the last page. All the homework that has to do with the quiz is the last page. The last page at the top says, quiz, da da da. And then, from there, go fill out as much as you can. But we only got through one example of these transformations. So if you get stuck, I don't want you to practice it wrong. You do need to do the last page. You should start some of this, but if you get stuck, don't practice it wrong. Like, I'll give you some time tomorrow, we can re-go over it more after the quiz, right? But you have to definitely do the last page. You do that part first, because that's exactly the way the quiz is going to look like. Understand? Tomorrow I'll see how much you've been picking up here. Picking up what I've been. Oh, we gotta hang up our thing. We're gonna hang up our thing. So do that tomorrow. They're all sitting there waiting for you. In a messy pile. Have a wonderful day. Have a good day.
Thank you.
Well, there's your paper. Yeah, I've got it. Not a problem. Okay, so the range is a one, right? So if I were if I were to put like dots on all of these, right? If I were finding your order here, this would be like 6, 2, 6. I'm approximating your 10 minutes, so you'll be okay. That one's probably like 5, 1, right? Over here, maybe this is 0, gosh, 2.2. And what's that one right there? 3, 0, 0. And as you're looking at this, the lowest point on this graph is 3, 0. But when we talk about domain, we're only looking at the y values. So let's just look at our y values. 2.2, 2.2, 1, 0. None of them go below 0. But if I kept going, which I'm not going to, but if I kept going, then all would be above or equal to 0. So like the lowest y value for the range, the lowest y value on this graph over here on this axis, the lowest point is y equals 0. And then from there, all my y values are higher, and higher, and higher. And that's kind of like the x's too, it's just we haven't had any x's that don't go all the way yet to well. Thank you. You're welcome. Oh gosh, it's so